Today I'm going to be talking about acid-base balance, how it deals in EMS. Some objectives we're going to go over today are describe how to determine pH, an acid, a base, and a buffer. We're going to compare and contrast the three different buffer systems. We're going to look at the different values between respiratory alkalosis and acidosis, and also metabolic acidosis and alkalosis, and evaluate some of the common causes of all of these. pH. So what does pH mean? pH basically stands for the potential for hydrogen. A pH scale starts at 0 and goes to 14. Anything less than 7 is an acid, and anything greater than 7 is a base. And the pH scale basically represents the concentration of hydrogen ions and hydroxyl ions in the fluid that you are testing. So the neutral point on the pH scale is 7. The normal pH of the body is around 7.4. So basically, your 14 is the highest of your bases, and 0 is the highest for your acids. They start at the middle and work their way out depending on their pH. There's a formula to figure out pH. It's called a logarithm. And basically it's pH equals 1 over log times, or log of H positive, which is your hydrogen ion. So basically, to figure out a pH of hydrochloric acid, you would do log times 2.0 times 10 to the negative third, which would be 0.30 plus negative 3, which gives you 2.70. Due to the logarithm, there's a tenfold difference between each unit on the pH scale. So therefore, if you multiply by 10 for every point to increase or decrease on the scale. So acids. What is an acid? An acid is a substance that increases in hydrogen positive ions in water. So basically, how many hydrogen ions dissolve in water? So basically, when you start at 7, and if ever how many ions dissolve in water, you would go up until you get to that number, and that's how acidic that substance is. And so now what is a base? A base is basically a substance that increases in OH negative ions in water and a substance that decreases in positive ions in water. So basically, as a human, you're extraordinary sensitive to pH changes. The most material within the cells have a pH of 6.8. Your blood plasma is a pH of 7.35 to 7.45, which is also where, when you start figuring out your respiratory and metabolic acidosis and alkalosis, that will come into effect and be very helpful. And your fluid around the cells have a 7.2 to 7.3 pH on the pH scale. For maintaining life, your pH scale cannot go less than 6.8 or greater than 7.8 on the pH scale. And if it does, then you will go into cardiac arrest. Basically, your pH scale, you have everything that's a pH of 0 would be like hydrochloric acid, and then we'll go 1 through 14 and name some things. A pH 1 is your stomach acid. A pH of 2 is lemon juice. A pH of 3 is ice cold soda, vinegar. A pH of 4 is tomatoes. A pH of 5 is black coffee. pH of 6 is your urine or saliva. pH of 7 is distilled water. And like I said earlier, your blood is 7.4. pH of 8 is seawater. A pH of 9 is baking soda. A pH of 10 is the Great Salt Lake. A pH of 11 would be household ammonia. And the pH of 12 is bicarbonate of soda. So basically your carbonated soda water. pH of 13 would be an oven cleaner, some type of heavy duty cleaner to clean an oven. And a pH of 14 would be sodium hydroxide. Now let's talk about some buffers. Buffer is a substance, especially a salt of the blood, tending to preserve original hydrogen ion concentration of its solution upon adding an acid or a base. So basically, your buffer helps you fix if you're too acidic or too alkalotic by taking salt and adding to it or taking away from it. The principle of blood buffers include carbonic acid, carbonates, bicarbonates, monobasics, and dibasic phosphates, and proteins. Your hemoglobin is your protein buffer of the body. It helps with your pH balance. Your pH balance is carefully regulated by 3 different bodily systems, either your blood, your lungs, or your kidneys. So basically you have your blood, and then respiratory or metabolic. Your blood would be your bicarbonate or carbonic acid buffer. This is the first and quickest way for your body to regulate your pH. This buffer actually uses both your kidneys and your lungs with your blood. Basically, your erythrocytes is what is causing your reactions. About 80% of extracellular fluid buffering occurs by way of this buffering system. It's basically 20 parts bicarbonate to 1 part carbonic. your respiratory buffer system. It's the second fastest. It reacts anywhere from 1 to 3 minutes. It's basically triggered whenever your respiratory chemoreceptors in the brainstem detect a pH irregularity in your body through the cerebral spinal fluid. Basically, when you go into DKA or diabetic ketoacidosis, you end up having your chemoreceptors detect that you're acidotic. So therefore, you get rapid and deep respirations or Kussmaul respirations, and it's telling your respiratory system to blow off CO2 to help with the acidosis and bring down your acidotic level. Which basically would put you into respiratory alkalosis. And basically, by putting you in respiratory alkalosis, it's also helping fix your metabolic acidosis. Now, your renal or your kidney buffer system is the slowest. It can take anywhere from hours to days to maybe fix your acidosis or alkalosis problem, your pH in your body. But it also helps and provides long-term acid-base balance maintenance. It kicks in when the blood buffers and respiratory buffers are slacking off or basically not working or just taking too long to work. It tries to help out. Basically, your kidneys are regulating your pH by excreting excess hydrogen ions and also your HCO3 negative bicarbonate ions. If your pH of your extracellular fluid is decreasing, then therefore your kidneys are going to put off your hydrogen positive ions to help bring that back up, that pH back up in your extracellular fluid. And if your pH in your extracellular fluid is increasing, then it's going to put off your bicarbonate ions, excrete your bicarbonate ions to help bring your pH back down. So basically, your normal ranges for your pH would be 7.35 to 7.45, and then your capnography can also help you with your pH and tell you how acidotic or alkalotic your patient is. Any normal would be 35 to 45. Anything less would be your patient would be acidotic. Anything greater would be your patient's alkalotic. So some respiratory derangements would be if your respiratory acidosis would be caused by retention of CO2. Basically, your asthma patients, your COPD patients, patients with any type of respiratory problems. Your pH is decreased, your CO2 levels are increased with respiratory acidosis. Your respiratory alkalosis is caused by excessive eliminations of CO2, which basically would be you're breathing off too much CO2, you're hyperventilating patients, your patients that are in DKA, patients of that nature, which basically states that your pH is increased and your CO2 level is decreased. Your metabolic acidosis is caused by the production of metabolic acids, which means your pH is decreased and your CO2 level is normal. So you're basically any patient that would have a decrease in pH, but also are dialysis patients. Their CO2 level will be normal, but then their kidneys are not functioning correctly, so therefore they're backing up the renal system, which would cause their pH to be thrown off. Your metabolic alkalosis is caused by excessive diuretics, prolonged emesis, or too much bicarb administration. So basically, your pH is increased and your CO2 level is normal. So basically, patients that are CHF, they take diuretics and take too much, they can cause themselves to go into metabolic alkalosis. Patients that have been vomiting for days upon days, due to a sickness or something, and if you give a patient too much sodium bicarb, you could put them in the metabolic alkalosis. From basically, if the patient's in cardiac arrest and you give them too much bicarb, you can put them in metabolic alkalosis, which then to reverse that, you need to give them calcium chloride to help bring that other back up. So respiratory acidosis basically is the way I've been taught respiratory alkalosis, or respiratory and metabolic alkalosis acidosis is respiratory opposite, metabolic equal. So therefore your respiratory values would be opposite, your pH would be either high or low, and your PaCO2 would be, or your bicarb, PaCO2 would be opposite of each other. So if your pH was going down and your PaCO2 was going up, then that would be respiratory. And then you would determine if it was acidosis or alkalosis, depending on your pH level. There's numerous causes, some different ones dealing with certain different things. You have anything central, be any narcotics, overdoses, sedatives, alcohol overdose. If they have any lesions on their central nervous system or their spinal cord, anything causing any type of malfunctions in the way their body is sending off signals. Neuromuscular would be hypokalemia or botulism. A lot of your patients could get hypokalemic due to hypoventilation, not breathing off enough CO2. Also, your dialysis patients could be hypokalemic. They're getting too much potassium drawn off. Your thoracic or pulmonary would be pneumonia, smoke inhalation, or pneumothorax. Anytime you have a punctured lung, air gets into your chest cavity from pneumothorax and it's not fixed, it can cause respiratory acidosis because you only have one lung that's able to, you only have one lung to be use the buffer system, which is not helping, and you can't put off enough of your CO2 or anything to help with that buffer system to keep your pH level. Smoke inhalation, structure fire, your firefighters, anything, they go in, they get smoke inhalation, or people that are inside structure fires or any type of fire and get smoke inhalation, they can be respiratory acidotic due to the smoke getting in the lungs and causing all sorts of type of problems. You get swelling inside the trachea to keep air passage not going through, pneumonia, being fluid in your lungs, taking up space for your patients to exchange your CO2 and oxygen to help keep that pH balanced in the body. Any foreign body obstructions in your airway due to you not being able to get the air in to do the exchange inside the lungs, inside the alveoli for your CO2, pH, O2 exchange in the alveoli, keep the pH balanced. Some causes for your respiratory alkalosis would be anxiety. Basically, patients going into anxiety attacks, hyperventilating, not taking deep breaths to get the air in. They're taking short breaths and really fast, which is not allowing the O2 and CO2 to do their exchange in the alveoli. Pain, patients in pain and they're breathing fast because they're hurting. They need some pain meds to help them calm down. They're also hyperventilating due to that. Your fevers, encephalitis, and meningitis sedative. So basically, your fevers, patients, especially your kids, if they have fevers, they can go into seizures, which is going to cause them to stop breathing or not breathe normally like they should due to their central nervous system is compromised at the time due to the seizure, which is coming from a fever. Hypotension, that means basically you don't have enough fluid for the heart to pump, which causes a pH imbalance due to you don't have enough hemoglobin to carry the oxygen to the extracellular interstitial spaces to help with pH regulation. Your hypoxemia basically would be your hyperventilation patients, your CHF patients. Due to the fluid backing up into the lungs, they're not able to get air in because they're having trouble getting air in due to their filling up with fluid and causing their alveoli not to be able to do the oxygen CO2 exchange. Your pulmonary embolisms, basically anything that would go into the lungs to cause an obstruction for the CO2, O2 exchange within the alveoli can cause any type of respiratory acidosis or alkalosis. Any patient that is on a mechanical ventilator, if it's not set right, it can cause them to go into respiratory alkalosis due to it's blowing off too much or not, and they're not being able to allow that O2 and CO2 exchange. Sepsis patients, big one. A lot of your nursing home patients that are septic, that they have fevers, they have hypotension, their pH is off due to their blood's not able to take away the carbon dioxide and leave the oxygen because they don't have enough fluid or enough hemoglobin to transport all the oxygen. They have the fever due to an infection somewhere inside the bloodstream, and they also have they're not breathing adequately enough to get their CO2 and O2 exchange within the alveoli. And also cirrhosis. Basically, your alcoholics can have respiratory alkalosis because it relaxes them. They breathe off too much. Plus, they're going into a alkalotic state due to the alcohol. Your metabolic acidosis. There's some causes of renal failure. Basically, if your patient goes into renal failure, then they're going to become metabolic acidotic due to your patients. They're not able to get rid of the waste within the kidneys due to their kidneys failing on them. They're not able to produce the urine to get rid of that waste, and it's backing up within the bloodstream. Your diabetic ketoacidosis patients are going to be having Kussmaul respirations, rapid, slow respirations. They're not able to produce that O2, CO2 exchange in the lungs. Also, they're diabetic and it's putting off ketones within the bloodstream that is making them highly acidotic. Your ibuprofen overdoses. People that take too much ibuprofen for pain due to not wanting to take pain meds. Anybody that's constantly taking ibuprofen, messing up their liver, which basically is causing a lot of problems with the pH system due to the backing up of the waste, and the liver's not able to filter it out. Also with the kidneys, antifreeze ingestion, ethyl glycol intoxication. Now you shouldn't have to worry too much about that due to your antifreeze not having the ethyl glycol mixture in it now. They kind of taking it out. The companies have been, I'm guessing, been told to take it out by FDA. Any patient with diarrhea that's been going on for several days can be in metabolic acidosis due to they're just releasing the fluids constantly. It's water constantly going out, which is your hydrogen ions. Parental elimination and hydrochloric acid ingestion. If you get in contact with any type of hydrochloric acid, it could cause you to be in metabolic acidosis. Your metabolic alkalosis, some causes would be overuse of diuretics. Basically, your CHF patients can put them into two separate categories: respiratory alkalosis and also metabolic alkalosis, due to your CHF patients being on diuretics for excess fluid. If they take too much, they could put themselves in that metabolic and respiratory alkalosis. Any patient that has cystic fibrosis can easily go into a metabolic alkalosis state. That's dealing with your sodium chloride responsive. If you're dealing with your sodium chloride resistance, anybody that does chewing tobacco can cause themselves to go into a metabolic alkalosis state due to it getting rid of your sodium chloride, basically your water concentration inside your body that's regulating your pH scale. Any bicarbonate administration, penicillin, milk alkali syndrome can cause you to go into a metabolic alkalosis state due to your patient not being able to filter that out and keep you stabilized. Your bicarbonate administration, big time, would be your cardiac arrest patients. If you give them too much bicarb, you could send them into a metabolic alkalosis state, and then you'd have to try to reverse it and try to give them calcium to help build it back up, build your calcium back up, because your calcium channel blockers are blocked. So basically, if you had a pH of 7.20, a PaCO2 of 30, and a hydrogen bicarbonate or sodium bicarbonate of 16, your patient would basically be respiratory alkalotic along with metabolic acidosis. So you'd have a little bit of both going on there. And basically your patient would probably be in shock, and you would have to treat shock and know how to treat shock to get that patient out of your respiratory alkalosis and metabolic acidosis. If you have a pH of 7.60, a PaCO2 of 27, and a bicarbonate of 23, basically your patient would be respiratory alkalosis, and probable cause would be from hyperventilation due to a number of things, from patient having an anxiety attack or being in too much pain or having anything that could cause them to hyperventilate and blow off too much CO2 and not go through that exchange within the lungs with the CO2 and the oxygen within the alveoli, and they're taking slow, really fast, short, shallow breaths. It's not helping at all. If you have a patient with a pH of 7.12, a PaCO2 of 68, and a bicarbonate of 29, your patient is going to be in respiratory acidosis along with metabolic alkalosis. And that could be your COPD patients who've been COPD patients for a long time. It's basically they could also be in CHF by now due to numerous things, retaining fluid buildup. They don't get up much. They sit in a chair all day. Your rest home patients, due to them laying in bed or sitting in a wheelchair all day, and they had COPD, they can go and they're on oxygen, but they don't want to wear it because they don't want to be confined to the bed. then it can cause some problems. If you have a patient that has a pH of 7.2, a PaCO2 of 60, and a bicarbonate of 14, your patient's going to be in respiratory and metabolic acidosis, and that causes basically could be from cardiac arrest. Basically, that's your patients that you want to give bicarb and calcium chloride to try to see if you can help reverse it. That's some of your H's and T's, your hydrogen ions that you want to try to reverse in cardiac arrest. So you would give your bicarb to help and calcium chloride to help with those. See if you can reverse it and get a patient back with a heartbeat. That way they can try to help filter out some of that hydrogen ions to get rid of it. Some clinical features or clinical findings that you would find with respiratory acidosis would be an altered LOC, tachycardia, any type of cardiac dysrhythmias, diaphoretic patient, if they have a headache, any abnormal breathing, visual disturbances, anything in that category could be a sign of respiratory acidosis. So you should always be doing good patient assessments, being sure you can identify these things. Your respiratory alkalosis would be circummoral paresis, or paresis, visual paresis, your carpodal spasms, an altered LOC, like your respiratory acidosis. You can have seizures, and basically all of these are related to a neuromuscular irregularity. So therefore, or irritability. So basically, your patients could anything dealing with neuromuscular irritabilities could put your patient into a respiratory alkalosis state. That's where your patient assessments like before come in handy. Always do good patient assessments. Make sure your patient assessments are the same for every patient. You go through every detail of it just to be sure that you get it done. Your metabolic acidosis clinical findings could be tachycardia, any pulmonary edema from your CHF patients, cardiac dysrhythmias or decreased cardiac output. Any patient that could be on dialysis who has an ejection fraction that isn't normal or in a normal range could be. Put your patient in metabolic acidosis. Any patient that is breathing fast or tachypnic could be a sign of metabolic acidosis. Taking deep breaths, slow, shallow deep breaths, and confusion or coma. Any patient, basically like your diabetic coma patients or your DKA patients that have not been knocked out due to not being able to put off that acidotic state. Metabolic alkalosis, any neuromuscular irritabilities, seizures, delirium, hyperreflexia, cardiac dysrhythmias, headache, abnormal breathing, pretty much about the same that was with your respiratory. Alkalosis can also be metabolic. You just have to do a good patient assessment to see if you can determine if it's respiratory or if it's metabolic, just to try to figure out which one is which. basically now students should be able to describe the difference between the pH, acids, bases, and the buffer systems. You should be able to compare and contrast the three different buffer systems. You should be able to arrange and identify what normal pH is, the range for normal pH, the range for normal PaCO2 or PCO2, and a normal for your bicarbonate levels, so that way that you can determine if your pH is respiratory or metabolic, acidosis or alkalosis. You should also be able to determine certain common conditions that help identify if it's a metabolic alkalosis patient or metabolic respiratory or metabolic acidosis patient, and also be able to tell if it's a respiratory alkalosis patient or a respiratory acidosis patient off of some of your clinical findings, along with also your patient assessment and your values for CO2. You can have several different ways to determine CO2 through your monitors in the EMS field. They have ETCO2, which can go on top of ET2, where they also have nasal capnography, which you plug into your monitor, and it uses expelled air out of your patient's mouth or through the ETCO2, ET2, whenever you squeeze the bag to make a breath, and then the air that comes back up, it helps determine your capnography levels, and you can also see a waveform on your monitor to help determine to see what it is. That way, if your patient is too acidotic, you're blowing off too much when you're bagging an intubated patient, you can say, well, okay, I need to slow down on my bagging so I can build that CO2 back up. And also, it helps with ROS. If you get your patient back, you get a heartbeat, your CO2 levels automatically going to spike upward, and then you shouldn't try to blow off that CO2 or that CO2 once you see the spike on the monitor from ROS, due to you need to allow your patient to, in CPR, to help circulate some of that through the body to help it get to certain points to where it can get it out, get it back to the lungs, so that way you can bring it down slowly and not really fast. If you bring it down really fast, you can cause the patient possibly to go back into cardiac arrest, and then you got to do it all again. And with your nasal CO2 capnography monitoring, you can use it on your respiratory patients, COPDers, CHFers, to see what their CO2 is, see if they're retaining CO2 and not blowing it off, or if their anxiety patients are blowing off too much due to hyperventilation. You can see what their CO2 level is. That way you can kind of help with bringing that, try to calm them down, get them to slow their breathing down, take slow deep breaths in through the nose, out through the mouth, trying to get them to retain some of that CO2 and not blow all of it off, because eventually if they blow too much CO2 off, the brain's going to realize it, knock out their respiratory drive, cause them to pass out until it can build it back up, and then it'll keep their respiratory drive kick back in and allow them to start breathing again on their own, and not cause them to be passed out as long. That's pretty much all I have on acid-base balance.